So, Zhenis group for the topic our Iws Schrodinger's equation, and the first is the content of Iws. The first is Schrödinger was the first person to write down such a wave equation. Much discussion is centered on what the equation meant, and the eigenvalues of the wave equation were should be to equal to the energy levels of quantum mechanical system. And the best test of the equation was when it was used to solve for energy levels of a hydrogen atom, and the energy level were found to be in accord with Reynolds law. It was initially massless, obvious what the wave function of the equation was, and after much debate, the wave function is now accepted to be probability distribution. And the Schrödinger equation is used to find the allowed energy levels of quantum mechanical system such as atoms or translation. This cohesive wave function gives the probability of finding the particle position. And the next is a table of contents. The first we saw the Schrödinger's equation and the Schrödinger's wave equation derivation. The next is the Broglie's hypothesis of matter wave. The next is conservation of energy and the important question for Schrödinger equation and the conclusion. The first topic: what is the Schrödinger wave equation? Schrödinger wave equation is a mathematical expression describing the energy and the position of the electron in space and time, into account the matter wave nature of electron inside an atom. And it's based on three considers. The first is a classical plane wave equation, Rogel's hypothesis of matter wave, and the conservation of energy. Schrödinger equation give us a detailed account of form of the wave function of probability waves that control the motion of some smaller particles. And the equation also describes how these waves are influenced by external factors. Moreover, the equation makes use for energy conservation concept that offers about the behavior of an electron that is attached to the nucleus. And besides, by calculating the Schrödinger equation, we obtain which helps us determine the quantum numbers as well as the orientation and the shape of optinels where electrons are found in molecule of an atom. And the two equations, which are time-dependent Schrödinger equation and the time-independent Schrödinger equation. Time-dependent Schrödinger equation is present in this picture. We see the time-dependent Schrödinger equation in position basic is given as this formulation. I is the imaginary unit, W is a time-dependent wave function, H square is the H bar, and the Vx is a potential, and the H is a simulation operator. So the next is the Schrödinger wave equation. The time-independent Schrödinger equation is compressed form can be expressed as H is a Hamilton operator, E is the energy eigenvalue, and the time-independent Schrödinger non-relativistic equation. We see the next picture. And the next is a classical plan wave equation. So, a wave is distributed of physical quantity undergoing simple harmonic motion or oscillation about its place. The disturbance get passed on to its neighbors or synotional forms. In this picture, in this graph, we see the t equal to the 0, and the xy graph, we see the a 0. The next is what is the physical significance of Schrödinger wave equation. So, both concept of an atom are simple. but it cannot explain the presence of multiply urbanage and fine spectrum erasing out them. It's applicable only to the electron system, and the cylinder wave function has multiply unique solution representing characteristics radius, energy, and the amplitude. And the probability density of the electron calculated from the wave function shows multiply urbanation with unique energy and the distribution in space. And the Squander equation could explain the presence of multiply orbitals in the fine spectrum arising out of atoms, non necessary hydrogen-like atoms. And the next is we see this equation for the wave is a second order particle differential equation of scalar variable in terms and more space variable and the time variable. The one-dimensional wave equation is in this picture the amplitude y, for example, of planned progressive sinusoidal wave is given y, y equal to the a cosinus 2p divided lambda times minus 2pt divided t plus omega, where a is the maximum amplitude, t is a period, and phi is the omega phase difference of the wave, and t is the time in second. For a standing wave, there is no phase difference, so that y equal to the a cosinus 2p divided lambda times means 2pt divided t. And we know the u equal to the y divided t because a equal to the cosinus 2px divided lambda means 2p omega t. So the next we see the Broglie's hypothesis matter wave, and we see the Planck's quantum theory states that the energy of waves and the quantity such way h equal to the h divided 2p and v equal to the a divided 2ph, and so smallest particles exhibit dual nature of particle and wave, and the Broglie relevance of the corresponding wave as follows. And the next is a conclusion. So, what exactly Schrinder wave equation? The Schrinder wave equation is a magical expression that describes the energy and the position of an electron in space and time while according for electrons matter wave nature inside an atom. And the least application of the Schringer wave equation, the first is it's the foundation of wave mechanics. The next is it aids to study of atomic structure, and it reflects all of the wave-like nature of matter. And the next is it's the foundation of wave mechanics. And what does Schringer wave equation describe? Schringer wave equation describes the behavior of matter waves. That's all. It's the conclusion.